All right, in these three problems right here, we're going to be looking at some different kinds of functions that we're going to be looking at kind of a little bit more of the visual to them, just because of the fact that we're talking about exponentials or we're talking about logs. What's happening with the end behaviors? Okay, end behaviors are our limits as we go to infinity or negative infinity. So if you remember, we have exponential growth versus exponential decay, and then we have a log, because the log is an inverse of an exponential. And so we have kind of our basic logs and our basic exponentials. So if we're going to look at this one, we're going to do e to the 5x. It's helpful for me to kind of just draw a little bit of a graph. And this thing levels off at 0. And so if we were to look at the limit as x approaches infinity of this function, we're going to the right, we would be going up to positive infinity. And then if we were to do the limit as x approaches negative infinity of that same function, we would be approaching 0. All right, so exponentials are very different than polynomials or rationals. One side can go to infinity, the other side can go to a number. Not uncommon for that to happen. So if we're going to be graphing this one, I really kind of need to manipulate and kind of figure out what we got going on. We're talking about a log, and in general, logs kind of start with this main point of 1, 0, and have this look to them. So they do go up forever. They have a domain issue. They're not going to go to negative infinity. They're actually going to be going to negative 0. But that all may change, kind of depending upon what all of this stuff does to it. So let's kind of analyze all of this. So let's rewrite our function as a negative natural log of 3x plus 4. Okay, so we have some transformations that we have to take into consideration. This is going to take this graph and shift it up 4, and this is going to vertically reflect it. Okay, so our visual to this is if we vertically reflect it, instead of it being kind of going up, our graph is going to go down like that. We still have this vertical asymptote here, domain issue. And then we're going to shift it up 4. So instead of it crossing the x-axis, we're going to go 1, 2, 3, 4. And then it's going to basically start to kind of turn there. All right, so I really didn't do a whole lot as far as end behaviors go. So we have a limit as x approaches infinity. This one. So as we approach infinity, this graph is going to go down forever. So we're going to negative infinity. And then the other side, the limit as x approaches, we don't have the option. We have an asymptote. We have a domain issue. You can't log a negative value. And so we can't go to negative infinity, but we can go to 0 from the right. There is no 0 from the left. So 0 from the right of that function, which is going up forever. So positive infinity. Right? And then the last, we have a trig function, cosine. So if you remember what a cosine graph looks like, this. Our cosine graph is that oscillating cosine starts high and it goes low, and it does this over and over and over again. And then on the other side, same. So what would our limit be as x approaches infinity? Well, it's not approaching a value, it's oscillating. So for this function, it would not exist. And then if we're going to the left, no different. It's not approaching a specific value because, again, it's oscillating. So it would also does not exist. All right. So just a couple different takes and a couple different looks, different kinds of equations, then polynomials and rationals.